The picture you are looking at the moment is of the Hume Dam, about 16 kilometres east of Albury, at the junction of the Murray and the Mittamitta rivers. It was built from a period of about 1919 to 1936. When Federation was first formed in this country, the Murray River Commission was one of the first organisations formed, 1905 in fact, and the engineers from New South Wales, Victoria and the Commonwealth were given the job of coming up with a scheme of taming the mighty Murray River, which either ran in a flood in the springtime and a drought in the autumn. And many more people right down the Murray Valley could live on that river if they had a guaranteed water supply. So this group of men, called the Murray River Commission, were entrusted to carry out research work, and in the course of that they looked at 25 sites in the upper Murray to see where the dam would be. It would involve many other locks further down the river, totalling about 12 altogether. 26 were planned but only half were built. But the first thing was the master reservoir to hold the water. And all of these sites were looked at in the upper Murray, and the source of the Murray is not far from Albury. But most of those sites had solid granite about 100 feet down, and solid granite was very necessary for a dam of this construction. Finally, at this site, which is across below the junction of those two rivers, they found solid granite at an average depth of about 40 feet. They put down 158 test bores across that valley, which was about 1.5 kilometres. The concrete section you see on the left was built by the New South Wales Public Works Department, 300 metres long, and is of concrete. The curved section you see on the right was built by the Victorian State Rivers and is about 1.2 kilometres. It is curved because that followed the line of the solid granite, and that's been one of the problems of recent years. So the New South Wales Public Works Department had already built Burrinjuck, and they'd had some experience, so they brought a lot of equipment here and a lot of knowledge. The Victorians had already built Nagambie near Shepparton and some early works on the Eildon Weir. The Victorian wall was all of earth with a concrete core in the middle. There were actually 3 walls here. This is number 1. There's a small one down there and another one right down the other end. You cannot see it at this stage. There were 2 villages. On the left-hand side is the New South Wales. They had a village. We don't know how many people lived there, but I'll show you more later. And the Victorians had a village out of sight on the right-hand side of this picture. It was called Ebden. It is considered that by the mid-1920s there were about 1,200 men worked on the project. And then, of course, it made Albury, and to a lesser extent Wodonga, growth centres at that time. The picture we are looking at now shows a man in a rowboat. Before the river was tamed, the date of this picture is December 1919, just after the Governor-General, Sir Ronald Munro Ferguson, had turned the first sod. The spade he used on that occasion is still kept in the regional museum. It hasn't been used since. So that is what the Murray River looked like before the man set out to tame it. And that's what the Murray River looks like today below the Weir Wall. Here we see the Governor-General of the day, Sir Ronald Munro Ferguson. He was an ex-soldier who had come out from England, and he had the job of Governor-General. This picture shows the flags of the 3 states flying, the New South Wales, Victoria, South Australia and the Commonwealth, although draped over the dais is the Union Jack. But this was a unique picture because the states rarely used to fly their flags in those days. We always flew the Union Jack. The gentlemen, of course, are in military uniform, wearing pitch helmets, as was the custom, something we started to do in India. The map you see on the screen was taken out of the Border Mail of November 1936, and it shows the layout of the works, which a few additions which I have put in. The Murray River came down this valley here, and the Mittamitta came to this river here. And that's why it was called the junction. and the junction was the name given to the dam originally until it was discovered that Hume and Hovell actually crossed the river here in 1824, and it became known as the Hume Dam. And today the beach out at the resort out at the weir is called Boyd's Beach, because William Boyd was the first man, he was one of the convicts, the 6 convicts, who swam the river. So this particular map shows you that the New South Wales River, the Murray River, was over on that side. The man-made river on this side was made by the New South Wales Public Works Department. That's covered in the red. And that gave them a supply of gravel. That outlet was necessary for the water coming out of the valves here. Today it's the power station, of course. So that was the outlet for the power station, but it also gave them a supply of gravel. The New South Wales people first started, they had to scrape away a hill, and with the spoil from that hill, they built that rectangular levee bank, and that covered about 2/3 of the site on the New South Wales side, where they were able to work before they ran into water problems. The Victorians were able to do about 2/3 of their project free of water until they eventually too ran into water, and another big cofferdam was built right around and overlapping the other one, and that enabled both states to complete their part of the work. The bridges originally were there, and the stumps are still available today, although I can't find the stump on that side. Later on the bridge was shifted down here, it was demolished, and we have another bridge there today. The road around there is very much the same today, only major work has gone on in front of this wall in the last few years here at a cost of something like $70 million, and that has caused that wall to divert. Due to the fact that the curve that I showed you before was there, and a weakness occurred there. I won't go into that on this occasion, but that was one of the weaknesses, and a lot of remedial work to be done on the downstream side of that wall. No figures have been published, but we understand something like 70 billion has been done. There was a racetrack over here because the clay for the upstream side there came from that area there, and they called it the borrowed pit. They borrowed the soil. Well, today they've borrowed more soil from that area and landscaped it so you're not so much conscious of the hole in the ground. The Ebden Township was over there, and all you can find there today are a few avenues of trees and a few bits of concrete curbing. The New South Wales town was over here, and some of those streets are still there today. And if you drove to the weir today, you'd still come on that road and come down past there. And by the end of this year, you'll be able to walk and ride a bike over the wall, but not drive a motor car. The water tower is still in the same position up there, but may not be the same tank. This gentleman is standing on the bank of the Mitta River at the junction of the Mitta and the Murray River. And I once met a man who claimed he'd fished from that point there, and by a flick of the line, he could throw his line either into the Murray River or the Mitta River. That's why we called it the Junction Dam. We are now at work on the New South Wales side, scraping away the hill and with the spoils building the levee bank so that the rest of the work could be protected. The vertical concrete things you see over here will eventually support a railway line coming around to the concrete mixing plant. In the distance there you see a big piece of equipment. It's a dragline operation called a Bucyrus, made in England and steam driven. It had a driver and a fireman. The firm in England is still in existence today, but today they have diesel products. It was the only vehicle on the whole site that had Caterpillar tractors. Now the Bucyrus could pick up about 3.5 yards of soil and drop it into a machine over there that you'll see in the next picture better. So this is the stage of very much the pick and shovel men and horse and dray. Railway lines were shifted frequently, and on this side here, it's a narrow gauge that the New South Wales people bought from Burrinjuck, and is a 900 millimetre or 3-foot gauge. This picture shows the same area we were talking about before, a better picture of the Bucyrus. And here you see a gadget called a Chinaman. This loose earth has been loosened by explosive. The Bucyrus will scrape it up and drop it into that container there called a Chinaman. A dray will back in underneath there and take away a load of soil. And a dray could carry about 1 tonne or 1 yard of soil, and dray is yard spelt backwards. That's how we get the word. So that's about what one horse could pull. Now, strangely enough, in New Guinea, during the Pacific War, about 1943, the Americans were building airstrips with bulldozers and everything, but they still call a similar contraption to this as a Chinaman. This is very much showing you the pick and the shovel of the work down here. That's the type of work it was. But the soil was loosened by explosives, scraped up Brachiosaurus, the smaller bits were picked up by... Now, we're standing on the Victorian bank looking north, and the whole wall ran roughly north and south. So there's always the north end. The New South Wales had the north end, the Victorians had the south end. Here we're standing at the south end looking north, and you can see the levee bank that we've built along the bank of the Murray River. And the New South Wales work is proceeding inside that area. Now, the wall is actually coming out of the hill there. Up here you see that tall tower, about 25 metres high. That's the home tower of the Flying Fox, and it could move east and west on 4 railway line. Alongside of it is a chimney stack from the Kelly and Lewis steam generator made in Melbourne, and they were all over the works. And the gadget over here is the condensing tower where they recovered some of the steam that they had used. The New South Wales works area is in that site up there. The village where the people lived is up in that area there. But this is the beginning of the wall coming out of here. In the next few slides, we'll see an amazing difference occur here. We're still on the south side of the work looking towards the north, and so much work has been done here now. The New South Wales wing wall that has to be built up against the hill is rising slowly up, and there's the section I showed you a few moments ago, and the other landmarks are up there. Although the home tower, the Flying Fox, is in a different position, it can move east and west. But down here you can see where the men were digging down for 40 odd feet looking for that solid granite on which all the concrete would be placed. This was terrible work. It was eventually to extend about 1,000 feet or 300 metres across the floor of the valley, and it was referred to as the bull ring. And it was said that when a man worked down there, he lost his soul. An explosion would be set off down here, loosening all the rock. When the dust had settled, the men would go down and with their bare hand pick up the loose pieces of rock they could manage and place it in a box such as the one you can see there. When that box was filled, it was lifted out by the stiff-legged crane here, and another one came in. And that was the method of removing the rock, by bare hands of men, no gloves or anything. This also shows the scaffolding work that is being erected behind the wall to carry the concrete, or the conveyor which carries the concrete to all the work. And these long chutes you see down here are where they were shooting the concrete down for that particular purpose. The wing wall here on the New South Wales side is slowly rising. It is several metres thick, and there is that elevated railway line up there that I pointed out to you before. The conveyor belt was extended as the work proceeded further south. This gives you a closer picture of the size of the rock. This one piece of rock here didn't break up into small fragments. It had to be drilled in again and exploded, and the work went on. 3 men were killed here in this area in 1923. Some explosions had not gone off. I'm not sure whether it was gelignite or gunpowder or what they were using. The explosion didn't go off. The driver and the fire and somebody off the Brachiosaurus walked over the stone to where the damage was, and it is not known whether they used a shovel scraping up the loose powder and caused a spark, but an explosion occurred that killed 3 people. And that was a major setback to the early construction of the weir. Other than that, 1 man was killed on the wall in 1936, but they were the only deaths that we know of. This is the same area, more concrete as you can see. If you consider that this was around about ground level, you can see how this concrete goes down about 40 odd feet looking for that solid granite. But here you can see the scaffolding conveyor belt up here, that's as far as it goes, the stiff-legged cranes, men working down here looking like dwarfs all over the place, working in the bull ring. Again, we're looking at the same area. The interesting thing here is that the group of 3 men travelling across on the Flying Fox. The Flying Fox spanned 1,300 feet, which is 400 metres, from the New South Wales moving tower to the Victorian fixed tower. Could carry 10 tonne. That is really 2 city blocks in the city of Albury. Those men are travelling across there by crane on the Flying Fox. Also, you can see the wing wall gradually rising. You can see men working down there where today there are the valves, and where the railway trucks are is today the site of the power station. But of course they're working in the protection of a levee bank, so they're not troubled by water. And you can see the massive concrete that's going into the wing wall to hold that hill back after it was excavated. On this occasion, I'm looking south at the same area, and the first thing you notice, the untidy mess. These are called plums. They are lumps of granite weighing up to 8 tonne. They have been put there by the Flying Fox. It did this all the time. They have come from the quarry. They've been hosed and air jetted, and they make up 17% of the total volume of the concrete in the wall. It was an economic thing. It was a common practice. So every batch of concrete had plums jutting out the top of it, so that the next batch of concrete went on, fitted over those plums. There was no steel reinforcement used in the work at this stage, seeing it was below ground level, so much of it. You can also see the chutes bringing down the concrete all over the place, and there you can see the little gadget that could pick the concrete up off the conveyor belt and take it to wherever they wanted. All of this structure you see here is made of Oregon. The towers were about 50 feet apart, and they used Oregon because it came in longer lengths than Australian Oregon. The south side of the levee bank you can see right down there, and right over there is the tail tower of the Flying Fox on the Victorian bank. This picture is in the middle of 1924. Again, I'm in the same area, and again you can see the plums, but on this occasion you can see the cofferdam was built on the Victorian side. It enclosed 12 acres, or about 8 hectares. But the water is flowing through the wall here at the moment. There is concrete underneath that wall. Eventually we will get the valves in position up here, and they'll divert the water through the valves, then put a cofferdam round behind there and fill in that batch of concrete there, make the wall complete. But on this picture here, the scaffolding has gone much further, as you can see. On this occasion, we're at the south end on the Victorian bank looking north inside the cofferdam I was just describing to you, because there is the wall of the cofferdam. The cofferdams had steel panels on the outside, wooden panels on the inside, and 20 feet of earth in between. And all the panels were driven in with a pile driver. So building cofferdams was a major occupation of a lot of people. You can see these men right down here. Well, today this is the spillway. They're getting right down so the concrete for what now forms a spillway could be built. There is the Bucyrus there. Again, now it's on the Victorian side. It has been floated across the river on a raft they made. It weighed 70 tonne, so it could do work on the Victorian side. The scaffolding is much further. You can see the conveyor belt there, and there's a chute coming down there. And here you can see the scaffolding will rise even higher, because as the work went up, the scaffolding had to go up and the conveyor belt was lifted. In the background you can see the wing wall on the New South Wales side is taking shape. Today you couldn't find that because of the amount of soil that's piled up against it. It's lost in all the structure. So that gives you a view inside the cofferdam, and you can see the tiny men down there. In this picture we're also standing south, a little bit higher. We're up on top of the tail tower on the Victorian bank. And here you can see the cofferdam that I was talking about. Now you can see we've poured a lot of concrete into that area we were just talking about before. And this, you can see the shape of the spillway starting to take shape there. Down here you might notice a train. Well, the Victorians had 10 of these engines. They were 3'6" gauge or 1,050 millimetres. They use the same gauge today on the Puffing Billy. The Victorian Railways had several narrow gauge railway lines. One ran from Wangaratta to Whitfield, but it's the same type of thing they're using as Puffing Billy today in the Dandenongs. So the New South Wales wall is taking shape. The valves eventually go in that position there. Here for the first time you see a steel tower. Now this steel tower was to be about 120 metres high and was to elevate concrete from the conveyor belt down here for the purpose of building the Victorian end of the wall. I'm on the Victorian bank of the river, and for the first time I'm showing you that concrete structure coming out of the ground. There was trouble here in 1925. They could not find solid bottom. They went to 40 feet where they usually found it, and they went to 50 feet and to 60 feet and to 70 feet. Finally at 90 feet they found solid granite. The engineer on the New South Wales side resigned because of ill health. The engineer on the Victorian side died because of the strain. It was considered calling the whole thing off. It was one little soft spot they'd missed in test drilling the area in the early part of the century. The Victorians were so anxious to finish the weir so that the soldier settlers further down the river would have a guaranteed water supply that they pushed on. And this is where the weakness has occurred of recent years. Finally, that concrete structure has come out of the ground and it now goes down about nearly 30 metres into the ground. It will rise to a height of about 35 metres and it is the joining point between the New South Wales and the Victorian walls. The tall tower you see here is very, very high, is of steel for the first time instead of wood, and it had an elevator in it to lift the concrete so they could build that tower. Now alongside that tower you see that wooden structure about 25 metres high. That eventually has to be elevated on top of that tower. That seemed an enormous project at the time. Now this tower has risen finally to a height of 40 metres. And the wooden tower that stood on the bank, 25 metres in height, is now dismantled. It's made of Oregon and has to be assembled on top of this tower here. It was a mystery for many years as to how it was done, but eventually I discovered that in the middle there's what is called a flitch of Oregon. It was a massive piece of Oregon, about 25 metres long, and it was hoisted up there, complete with the block and tackle on the top and held by guy wires. And using the pulley on top of that pole, they lifted up each side of the Flying Fox here. And when they had both sides up, they lifted up the horizontals and the diagonals and bolted them in position and secured that tower, the wooden tower on top of the concrete one, and it was reinforced by guy wires all around the countryside because of the strain of the cable from the Flying Fox over on the other side of the river. So that was a major achievement. Eventually a wing wall will come from here right down here, across here. And now in the distance over here we can see the Victorian wall coming across country. There's a core concrete wall in the middle and there's soil on the upstream side of each side of that. But in this picture here, again you can see the spillway is taking shape and you can see those bolts jutting out there. Every batch of concrete they put in bronze fittings to take those bolts to hold the next lot of boxing. And as they went the next lot of boxing, they took those bolts out, but the bronze fittings are still there today. All these chutes here are where the concrete's been directed to where they want it to. But the main thing about this operation is getting this wooden tower on top of the concrete tower so the Flying Fox could cover all of the work. That long thing hanging down there is a chute, so they could shoot the concrete wherever they wanted it to. We're now looking at the same area on the north side, looking at that area down there where I was showing you before. You can see there's the cofferdam and there's the spillway work we were talking about. We have the wooden tower on top of the concrete one. But note here how the scaffolding is going higher and higher because the conveyor belt is lifted all the time, eventually as high as that area there, to lift the work. Now this is 1928, and you can see some of the valves are in position. There are 7 valves, but the water is still coming through that section there. When we get the water through the valves eventually, we will block that area off there and fill that concrete there. Of course, the Weir employed lots of carpenters. There were no welders. There were no metal workers as such. Welding was not known. Everybody tended to be a carpenter. Everything was carpentry. Now inside here you can see the cofferdam or the spillway work that we talked about before is all happening. The conveyor belt is over here. The tail tower is on top of the concrete one there. The Victorian wall's coming across country right up to here. This area here goes over that and it's concreted a little bit further downstream of that again. But today there's just raging water there. On this occasion here there are railway lines. You can see the untidy mess of the plums waiting to be put in the next batch of concrete. Over in the distance over there you can see parts of the Victorian village called Ebden, right over yonder. The road you see along there is in very much the same position as today. It has been diverted by works of recent years there. Now finally, in August 29, water came through the valves for the first time and flooded a few bridges in the area. August 29 was when water was contained for the first time. This shows you the valves in place, and the New South Wales wing wall is still happening up there. Next picture I'm going to take you behind the wall just up to there. Because this picture shows you those concrete structures on the water line. They are the trash racks to prevent logs and things to go in through the valves and the turbines. They have never been seen since that occasion. Of recent years, divers in diving gear have been doing remedial work down on those trash racks. Again, you can see on top of the structure, the conveyor belt going up. One belt drops the concrete onto another belt and it carries on. And on the Flying Fox going across there, it looks like a toilet. The men at least had some creature comforts, even at that time. They didn't have many, but obviously they had a toilet. And just there you can see a roof over there, because obviously concrete was spilt off the conveyor belt, and to protect the men working down underneath, that is the roof. Again, you'll notice the structure of Oregon, and you'll even notice the steps on there that are step ladders. All of these towers had steps like that, and they were considered safe enough for men to work on in the 1920s. Today, of course, we just wouldn't dream of that sort of thing. But there were very few accidents. We don't know why, really. Again, this shows the same area, although it's dated 29, and the hole in the wall has finally been filled, as you can see there, and the spillway is starting to take shape, and so is the wing wall on the Victorian side. Again, there's a very long chute taking concrete right down to work right down here. This area is inside a cofferdam at the moment, and that's the dry area on the other side of it, because they plugged up in the hole where the wall was coming through. The same valves are still in place today. In front of them today, of course, some of them go through a turbine, so we don't see the valves so much. But you can see the spillway taking shape, and it's all happening. This structure here shows you concrete formwork in the spillway. The big structure on the right is all made of timber. It's on wheels so it can be moved along, and the chutes up top are carrying the concrete down so that they could, when they did one batch of concrete, when that was dry, they shifted along. Over on the left you can see structure bolted on there. Well, they were the bolts that I referred to before. For every batch of concrete, they put these copper fittings in that took the bolts for the next batch of concrete. Again, you can see the massive wooden structure up on top. In fact, everything you see in the picture is of timber, except the men who are standing there. And it looks like a couple of engineers down here on the left who are dressed in collar and tie. Again, the spillway is starting to look finished. Wouldn't the boys on skateboards love it today? But of course today it's full of raging water. The water only comes over the spillway. At that time there were no floodgates in the original project, so water came over the spillway every spring. Today, because of floodgates, it rarely comes over. Now here is the near completed structure that we've been building all this time. It is eventually to have 28 columns on top of it to support the roadway. But on this occasion here, the water's not over the spillway, it's coming through the valves. The scaffolding is still there, and there are some very dark clouds in the background, and somebody has used a filter to take this effect. At this stage, I will leave the New South Wales wall, and we'll go over and see how the Victorians are getting on over on their side of the wall. This is a modern slide provided by the Murray River Commission, shows how the core wall goes down into solid granite. It shows the inspection gallery there on the right-hand side at the bottom, and it shows the coarse fill downstream and the earth fill on the upstream side, and the roadway is on top of it all. So as they built their concrete structure, remember 2 metres at the bottom and 1 metre at the top, and it's just underneath the road, they carried on with the earthwork as they went along. On the right-hand side of the picture here, you can see earth fill. Well, that is the work they're doing out there just at this day. This is 2001. They've been there for a few years. They've really built another wall in front of the Victorian wall to overcome any weaknesses on it. Over on the Victorian side, this structure you see here is underneath the roadway across the top. You can see the inspection tunnel on the downstream side of it. You can see a steam shovel there. They had slightly different equipment on the Victorian side. They had many cranes on railway lines. They called them steam navvies. This work had steel reinforcement in it, right from the word go, because it was so narrow. And because they had to go down so deep, the Victorians, being miners, put down a mine shaft every 100 feet or 30 metres. And when they found solid granite and went a couple of metres into it, they then drilled horizontal tunnels and removed the overburden. The result was they made a great big hole in the ground, getting this concrete structure into it. But that shows you what it was like, and they did use steel reinforcement. This again is the same area, and you can see the big hole they've made in the ground. You can see the massive amount of timber that they would have used for shoring up the mine as they went down. You can see the horses over in the distance, and you can see the railway line on the right-hand side. Towards the back of the picture, the wall is further advanced. They had no conveyor belt here. They tended to mix the concrete on the site, but you're conscious here of the steel reinforcement all the way, and of the horses, of course. This again is on the Victorian side, showing their works area. The railway line looks a little bit wobbly here. They actually had 10 locos over here. They had no motor vehicles at all. The Victorian broad railway gauge came right to the site and brought any raw material that had to come from outside sources. The power station is in the middle of the picture. Again, it was the Kelly and Lewis steam generator made in Melbourne. Melbourne was the home of engineering because of its mining at this time in our history. Now, this structure here gives you a better picture of the Victorian structure. It is actually about 200 metres from side to side. That's about as big as the city block is in Albury, but of recent years it's been increased because they built more cofferdams or more walls in front of it down on this side here. But here you can see the clay on the upstream side from the Burrow pit. Here you can see the looser material on the downstream side, which came from a mine some miles out of Chiltern and was brought to the site by a Victorian broad gauge railway line and gave the Victorians a source of sand and gravel, which they did not otherwise have. As you can see here, the ground looks all pretty muddy. It has only been scraped off with monkey tail scoops. There were no bulldozers then. Some of the problems we've had with the Victorian wall are no doubt due to the fact that the ground wasn't scraped well enough in the first place to put clay on. Clay probably went on to decomposed soil somewhere. A lot of horses were kept in an area here. They had 500 odd horses, and where the horses were kept, the soil was affected by manure, so the strength of the soil was broken down. So they've been the problems that have occurred. But basically they put in concrete, they put clay on the upstream side and the looser material on the downstream side, and carried on like that. They were fairly free of water for about 2/3 of their operation. On this picture here, I'm east of the wall, standing in the middle of what is today the weir. On the left-hand side, you see the Victorian wall coming up from the south, and on the right-hand side, you see that tall tower we built with the wooden tower on top of it on the northern side. And you can see somewhere the gap there that the Victorians have to fill in. In the foreground there, you can see the horses and drays, because they had 500 horses on the Victorian side. But what you're looking at today is all the bottom of the Lake Hume. I've sailed over that many, many times. I was a yachtsman there for over 30 odd years. But that all lies underneath the waters of today. Even the tree would still be there buried somewhere. Again, we're looking at the Victorian wall. It's nearly up to the tower that we built earlier in the piece. You can see on the screen the slot, about 2 metres wide, that Victorian wall has to fit into. That caused troubles, of course. When that batch of concrete dried in against the other concrete, they left a gap for contraction and expansion, and they put in bitumen as a sealant. That was the best thing known at that time. In about 1930, this was happening. Time has proved that decision to be wrong, and bitumen has deteriorated and let water through, and that was one of the causes of the problems, again, of recent years in that area. Here you can see the monkey tail scoops. They were 2 horses or 3 horses, and they could shift about half a yard of soil, depending upon the ground the horses were working on. You can see a light railway line on top of the wall going out there that's obviously been used for carrying out concrete. They put out that concrete wall in batches of about 40 or 50 feet, and they obviously mixing the concrete on shore back at the base and bringing it out here. But you can see the Bathanga gap right up there on the right-hand side of the picture. I'm at the south side of the Victorian structure looking north, and here you can see the muddy mess on the right, because that was the clay. It was kept wet all the time, and it was considered that the hooves, a horse weighed something like a tonne and stood on 2 feet at any one time when it was working, and the hooves of horses compacted that soil as well as anything they had at that time. Horses were in mud up to their bellies. They were the conditions under which they worked. On the downstream side, you'll notice the soil is dry. The theory was that we'd build a wall out of clay and it would dry hard like a brick and water wouldn't get through. If it did get through, the wall was there to stop it. And if it did get through the wall, we'd have a tunnel and a drain there, and we could release it through the porous material on the other side. That was the thinking. And most of those things have happened. And you can see the steel reinforcement riding up out of the concrete there, because with such small section they used steel there. Nobody knows today how that steel concrete has withstood the test of time. Nobody's ever opened it up to see if it's still there. The information I'm telling you today is public knowledge. I'm not telling you anything confidential. It's only plain common sense that normal people can find out and conclude from their observations. But as you can see, the Victorian wall is well underway at this stage and heading for that tower over there. Now, when all the clay was finished on the upstream side, this is 31, it was to be covered with concrete to keep it dry. This concrete was 12 inches thick and required boxing not around it but on top of it, and that's why the boxing looks so strange. There is concrete in the lower part of the picture. Down at a lower level, the concrete was put against a toe of rocks that were put there. But apparently things slipped here. As the concrete would then expand, there were half-inch joints between it all, and that too was filled with bitumen. And apparently we have now discovered that while the weir was finished in 1936, remedial work started almost straight away because moisture had got through all of this structure. So the remedial work seems to have been going on forever. But the concrete boxing looks so bulky because the boxing is on top of the concrete. Now this shows the Victorian wall just about complete. As you can see, all the major work appears to be done. There only remains the remaining work over on the New South Wales wall that we left some time ago. A roadway was to go along the top of that wall, has been closed of recent years, but I understand it will be open to pedestrians and cyclists at the end of last year. It was supposed to be, or maybe soon. The road you see at the foot of that structure has been diverted a little bit because of the extra work they have done there of recent times. The Pathanga Gap appears at the top of the picture up there. And the wooden tower we erected on top of the concrete one is still there. It won't be dismantled till all of the work has been completed. This is the New South Wales side. We'll go back and finish that. This is springtime when it flooded every spring, and work would be suspended on those columns at this time until the water went down again, and the men did other things. But on the left-hand part of the picture, you can see the roadway across the top is starting to take shape. But consider a few short years ago, we were digging holes in that very area. Now that has all been filled with concrete and it's performing its function as a dam. The Victorian wing wall is now in place, and it supports that earth embankment that comes across there. And the wooden tower is still up on top there, and the cable for the Flying Fox still spans that 400 metres across the countryside. This is in drier times. The water level's gone down, so this shows the capping on the wall over the top. It's the curved structure, and the floodgates fitted into a groove there. Also, you can see what will be the pillars rising up. By now, they have steel reinforcement in them because they're only about 1.5 metres wide, and they will eventually support the 29 gates. Because of the depression that occurred in 29, the gates were not put in. The whole project came to a halt. 300 men lost their jobs in 1929 because of the depression, but the structure still went in. And the floodgates were to slide up and down in those iron railings you see there and lift up above the wall, and the water was to go underneath. But when in the 1950s and 60s the floodgates were put in and the water level was raised over 8 metres, bigger floodgates were put in that lifted that water up, and the water now goes underneath them. In the original scheme, the water would have gone over the top of them, but now the water goes underneath. So they lift the floodgates up now and let the water underneath. In the original concept, the gates would have gone down and the water would have come over the top of them. But they raised the level of the weir in another project in the 1950s and 60s, about 8 metres, necessitated the shifting of Tallangatta roads and railway lines. And that was another project that hasn't been recorded yet. I hope somebody might do that someday. Mr. Newman was the last man killed in the weir here. He was blown off the top of this structure in 1936. His sons are still living in Albury. There was no compensation even for death in those days. There was great scope for improvement in social conditions at that time. The men worked, first of all, a 48-hour week and then a 44-hour week, and there were no holidays. It was hard work, but on the other hand, they were a very healthy community. This is 1935 on the Spillway work. As you can see, the road is all there. By the boxing up on top and to the right hand of the picture, there's still some concrete formwork going on there. You can see the tracks there where the floodgates would have gone on. This picture doesn't really do justice to the size of the project. If you went there, you would realise it's a much bigger thing than this picture shows you. It's hard to comprehend the measurements I give you when you go out to the weir. When the thing is 1.5 kilometres long, it's hard to believe in the open space in that countryside. It's a huge structure. Now this structure shows one of the gates. They actually put in 3 gates before a halt was called. As you can see, these gates are riveted together. Welding wasn't known at this point of time. On the other hand, all the structural members you see are of timber. So carpentry with timber bolted together was the way to make structures. Welding hadn't come, and riveting was the way to go. But 3 gates went in, but of course they were not effective because it was meant to have 29 gates altogether. But that was when the depression occurred in 29. You can see the men wear no unusual gear, normal hats, normal boots, and no gloves. It was a dangerous job. There were 4 deaths that we know of. They must have been tougher men. Notice the wooden ladder and all the wooden structure. That's the tail tower and the Flying Fox over there on the right-hand side. This is what the weir looked like in 1935 or 36 when it was finished. Note the wooden tower is still there, sitting on top of the concrete tower, but everything's been built up around it. That spillway is 700 feet long. That's the length of a city block in Albury. Yet when you stand on that wall today, it's hard to comprehend that. You can see the spillway that we built. That bar along there was to break down the speed. As the current came over the spillway, it came over at 90 feet per second. By the time it went over that lower structure down there, it was reduced to 60 feet per second. But you can see the Victorian wall is finished and it's planted with vegetation. You can see the New South Wales wall across the top is finished. The valves are down there. Today we have the power station in front of some of those valves. So that's what the completed structure looked like in 36. The structure we have on it today, of course, we added in the 1950s and 60s. Well, having completed the two walls, and there are two separate walls joined together, we'll now deal with some of the equipment. This is the Flying Fox, the home tower on the New South Wales side that ran on 4 railway lines that had no cables holding it and ran east and west about 180 feet in each direction. It could lift 10 tonnes and it spanned 400 metres. That is like 2 city blocks in the city of Albury and the city of Melbourne. I don't know how thick the cable was. It was all driven by electricity. A man sat up the top up there and he could make that tower go east and west. He could make that cage go across the whole area and he could make it go up and down. It was weighed down with about 300 tonnes of concrete on the bottom, was made of Oregon and was about 25 metres high. On the left of that is the power station for the Kelly and Lewis steam engine, and there's one of those steam engines out there today. And on the left of that is the condensing tower. They generated their own power out there. They considered hooking onto the Albury City Council at the time, but the plant the Albury City Council had just put in was not big enough capacity to meet their... This shows 2 men in the Flying Fox cage going across the weir. I suppose it was a bit of a thrill in those days, the closest of these chaps ever got to flying, to be lifted up above the ground and carried out into space. It gives you an idea of the mechanism up above there. I don't know how thick the cable was. It would span 400 metres and still support 10 tonnes of weight. The monkey tail scoop was 2-horse or 3-horse. They had about 500 horses on the Victorian side. Was the latest method of moving soil at that time. And even after the weir was finished, a lot of the irrigation ditches further downstream were excavated with monkey tail scoops. There became a bit of a problem when the steeper the bank became so steep the horse couldn't pull the weight up the hill. But they were the main things used. So after they were finished here, but some of them were taken down to the Yarrawonga Weir. The Yarrawonga Weir started almost as soon as the Hume Dam finished. A part of the Flying Fox Tower and a lot of other equipment the New South Wales Public Works Department took down to the Mulwala or Yarrawonga Weir instead of selling it here. Ebden was a railway station a couple of miles away from Victorian village, and this slide shows unloading sand or cement. Well, now anybody would know that they are bags of chaff, because had they been sand or cement, nobody could have ever handled them. There were 500 odd horses on the Victorian side, and all the local farmers out there used to supply feed for those horses. And one particular family was the Rapsey family. One of the Miss Rapseys is still alive today. So they're bags of chaff. The New South Wales side didn't employ a lot of horses. The Victorians employed an awful lot of horses. The Victorians had no motor lorries. The New South Wales people did have some motor lorries. This is the engineer's workshop on the New South Wales side. It has a lathe, a drill, emery wheels, hacksaws, and all those sort of things, and a water bag hanging up on the left. There's no mention of welding here, but at this time, mention is made of oxy and arc welding in the Victorian workshop at this time, but there's no evidence of it on the New South Wales side. But that was the workshop where they serviced all their equipment. I suppose anything they couldn't handle there, they sent it away to Sydney or Melbourne or to Albury if it could be repaired there. But they were a pretty self-supporting community, very capable staff. This is a traction engine. When the scheme was planned in the early part of the last century, it was envisaged they would use traction engines, especially from Albury out to the Weir, because that was the latest technology. And this gentleman, you notice, is wearing a collar and a tie. He's taken his coat off, but he's smoking a pipe. He is enjoying the latest technology because that was the latest way to go. Fred Heath, who is still alive in Albury, he's in his 90s, remembers in 1919 two traction engines going out past his father's property at Willinga, towing out the crushing plant to take out to the Weir, to open up the quarry, to get the stones, to make the road so it could all happen. And they were towed by traction engines. And this gentleman, he's enjoying the latest technology. He can drive a traction engine. He's like a jumbo jet pilot of today. They didn't need chaff to feed him, they only needed firewood. And the engines were very simple steam engines. There's two of them in the Cumberuna down at Albury at the moment. But they'd probably developed about 20 odd horsepower. They had safety valves and they had a big wheel there that would drive a chaff cutter, a sawmill, a pump, a flour mill, a sawmill, anything you wanted to do. They were a mobile engine, and that was the way they planned to go. Another version of the traction engine was the steamroller, and every council tended to have one in those days for making roads. In this occasion here, it's towing a trailer with the nose of a valve on it, so they were used for general transport work. Obviously the handbrakes weren't so good by the look of the rock underneath the wheel. So that was the way they had planned to go in the early part of the last century. But there's a new invention during the First World War that changed all that. It was something we take for granted today, but it was a motor lorry. That invention was the motor lorry, and this is the Thornycroft, available from disposals in 1919, and that revolutionised transport, road transport. They had solid rubber tyres. They had a top speed of about 17 kilometres per hour. They towed trailers. They could carry 5 tonne. And the New South Wales Public Department bought 10 of them. And they had a depot in Albury at the intersection of the railway line and North Street. And all of the weirs, coal and cement came from Wollongong, plus other suppliers around the area. And they were unloaded at that depot on the railway line, and these 10 trucks ran a shuttle service from that depot to the Weir all of the working day. The road was bitumen, but it had 2 grooves in it from those solid tyres. And they were really the first motor lorries we saw in Albury. Not that I saw them, I wasn't around then. But those 10 trucks carried everything out to the New South Wales side that you see there. Every bag of cement, every tonne of coal, every nut and bolt, every piece of timber, every piece of machinery, every railway engine, the valves, the Flying Fox, the Brasiris, everything other than the crushing plant for the quarry. It went out by but they were workhorses. And after the war, they were sold. And I think they went on forever. I think you had to be a bit of a Superman to drive them. With only a very slow speed and solid rubber tyres. But they changed motor transport. There were still motor vehicles like that running around in Albury in 1930 on solid rubber tyres. This shows one of those vehicles backed into the concrete mixing plant. It doesn't look a very sophisticated building, but inside that building they would handle 3,000 to 4,000 bags of cement a day. This is when they were pouring cement. And in an 8-hour shift, they'd turn out about 1,000 cubic yards of cement and feed it onto that conveyor belt and feed it to all parts of the Weir across as far as the Victorian Bank when they needed concrete. Now, there was a great shortage of concrete in the 1920s due to post-war development, and they always kept a supply of about 25,000 bags here and about a similar number of bags in reserve in their Albury depot in case they ran out of cement. On the right-hand side of the picture there, you can see one of the plums on a little railway line going past. But so that was the concrete mixing plant that mixed all the concrete. This is on the Victorian side, and it's a rare picture, shows a steam engine being transported by lorry and pulled by horses to another site. They had occasion to shift steam engines quite a lot, and usually they shifted railway lines and ran them along, but for some reason we don't know, on this occasion they decided to transport the engine on a horse lorry. It probably weighed about 15 tonne. They were the same gauge as Puffing Billy is in the Dandenongs today. And the Victorian government always ran a narrow gauge railway line in hilly country instead of their broad gauge. So this is a pretty rare picture. This shows the pile driving exercise mounted on the punt. The punt was originally made to take the Bucyrus across the river, and it weighed 70 tonne. And I remember talking to a man, he said it was an exciting moment when they drove the Bucyrus onto that punt for the first time. With its massive weight and caterpillar tractors, they didn't know whether the punt would collapse or not. But it took the strain, and they took the Bucyrus across the river and eventually brought it back. A few years later, that punt was to play an important part when the bridge at Tallangatta went underwater, and that punt became a temporary punt near the Tallangatta Bridge, but more about that later. That shows the pile driver, and there's a cofferdam they're building somewhere. You can see the Victorian wall over there in the distance. So this is downstream of the weir somewhere where they're building a cofferdam. They had boats, a fleet of boats. They had a big motor launch on the weir later on, a big 45-footer with a couple of Chrysler Royals in it. But that is the pile driving equipment, all made of timber. This picture shows some of the equipment on the New South Wales side. They only had 4 engines of 900mm or 3-foot gauge. They'd brought them from Burrinjuck, but they had about 100 odd trucks. 30 of the trucks were like these trucks in the foreground for carrying stones, or plums as they called them, and the other 70 were for gravel. It came from the quarry. An engine towed the empty trucks around to the quarry. The quarry loaded the commodity onto the vehicle and released it, and it came back by gravity to the concrete mixing plant or to the works area. So they only needed locos to take them there, not to bring them back. And they only had 4 locos, whereas the Victorians had 10. But then they had trucks on the New South Wales side, and they had no trucks on the Victorian side. But this picture shows the wing wall complete, the wall built, the tail tower, the Flying Fox is still over there. You can see the conveyor belt going up there, and the Victorian village right over in the distance over there. This shows one of the plums being hosed, and they were all subjected to air jetting before being bedded in concrete. And as I said earlier, it makes up 17% of the total volume of the concrete. The batches of concrete they used were tested all the time at certain intervals. Every day batches of concrete were put aside for testing, and the mixture varied according to what they were doing. I won't bore you with all those details, but they are available. But all the samples that they tested always stood up to the test. So there's no trouble whatever with the concrete. Concrete hardens with age. An aerial view of the New South Wales township. The road from Albury comes in there. The water tower is still in the same position, and the road goes down there, and today it goes across the wall there. But at the moment, all that area down there is works area. The railway line followed that contour right around there, which is roughly the beach, where they went to and from the quarry around near the Tallangatta Bridge. This obviously was taken in 1924, when for the first time in our history an aeroplane was in Albury and took aerial photographs of the 1924 celebrations, which was 100 years since Hume and Hovell had gone past. So that gives you an idea of the village. There's no details kept on how many people lived there. The information I've got largely comes from the yearly report of the Border Mail and things that I've been able to read. Altogether, about 1,200 people worked on both sides of the weir up till about 1928, when 300 men lost their jobs. There was accommodation for single men and for married men, and houses were small, but they were built with 1, 2 and 3 bedrooms. And there was a school on both sides, a primary school, a secondary school the children had to go into Albury. This shows some of the cottages on the New South Wales side. They were humble. The people were supplied with firewood and water and electricity for lighting only. And the lights went out at 11 o'clock at night. And all respectable people should be in bed by 11 o'clock at night, shouldn't they? Of course, there was no sewerage, but they were a very healthy community. There was a doctor on the New South Wales side, and he had a motor vehicle and a telephone. And he even treated people on the Victorian side. But they altogether were a very healthy people, probably healthier than the citizens of Albury. The area was well drained. They were hard working. There was no hot water system then, of course. If Dad was to have a hot bath when he came home after a day's work, it would be by courtesy of the water heated in the copper, or there might have been chip bath heaters. But they were pretty primitive days in those days. The men could buy their own homes and have 12.5% of their salary deducted every week, but then when they got the sack, they couldn't sell the house. So it was difficult, really. They had, I won't say shopping centres, but they had commercial shops in both villages. They had a grocer, and tradesmen called every day. The butcher came and sold the meat from his cart, and the milkman called, and the greengrocer called, and the baker called, and the iceman called, for those people that had an ice chest. They didn't have any private telephones, and there were no electrical gadgets, and Albury didn't get any radio until 1930, so living was pretty simple. They had a 9-hole golf course where the trout farm is today. For Saturday night's dance, if they were having a good time and the lights were to go out at 11 o'clock, they'd take up a collection and take 10 bob down to the fireman at the power station and ask him to shovel the coal in for another hour so they could dance till midnight. It has changed a little bit since then, hasn't it? In the foreground over there you can see the Victorian wall, the Victorian village, and the road across the flats, and a lot of the structure up here. It's a very early picture, really, but it shows the living conditions. But people lived healthy lives. There are people today in Albury, whom I know, who were actually born while their parents worked at the weir. Another view of the living conditions. These show the barracks where single men, 2 men, shared a room. They had a steel stretcher with a straw palliasse on it. They were pretty primitive conditions, and they ate their meals in a mess, and there were also private boarding houses for those that could afford it. The wages, of course, would have been $5 or $6 a week. Working hours would have been 48 at first and then down to 44. On the New South Wales side, they fielded a very good football team in the Ovens and Murray. On the Victorian side, their team was in the Chiltern and District. Now, these 2 gentlemen are a bit unusual. They're surveyors. Their camp was down where the fish farm is today, and they were in a tent with a metal fireplace. But actually the tents had a metal fly over the top of them and had fly wire doors to keep the flies out. Both of them are wearing their oversized RSL badges, and preference was given to returned men. The work could have started in 1915, but it was decided to hold it up to 1919 to give employment to the men home from the First World War. And most of these fellas on the weir had served their country in the war and then served their country working on this Hume Dam. But these gentlemen obviously got dressed up in their best clothes, pipes and all, for the purpose of the photograph. This picture has nothing to do with construction, it's more to do with recreation, but it shows a group of people dressed in their Sunday best crossing a stretch of water on a pontoon pulled by a man on a cable. Had they all gone to one side, the thing would have capsized, and I guess they all would have been drowned. Swimming wasn't very common at that point of time. One gentleman was wearing a dust coat and a pitch helmet, and that was the type of gear you wore when driving the motor cars of that time, because cars were dusty. Some of the gentlemen are wearing Panama hats. But it just shows that they have strange ideas on safety for a group of people to have been pulled across water like that. I don't know exactly where it is. These are some cottages on the Victorian side that we know of. The one at this end has a veranda, the one in the middle does not. I suppose the wife wanted some creature comfort. They tended to be reddish in colour because they were painted with creosote to protect against white ants. At the big disposal sale held on both sides of the weir in 1936, everything was cleared away and buildings and equipment and structures went all over Australia. 8 of these houses finished up in Albury at the bottom end of Macaulay Street. They're still there today, a couple of generations later, still housing people. They don't bear much resemblance to this. Somebody's bought these houses and reshaped them on their present site. But buildings and vehicles and equipment went all over the countryside at the big disposal sale. I don't remember the disposal sale. I was possibly too young at the time, but it must have been a used affair that probably went on for a week to sell all the equipment. These are some men. We don't know anything about them, but most of these pictures were just got by accident, so we don't know where they came from. But these are a group of men obviously taken on Sunday, when everybody apparently wore a white shirt, and one gentleman has a tie on, a collar and tie and a coat. But they were typical of the people who served in the war and then built the Hume Dam. And we should be grateful to those people because they served us in 2 different spheres. This is a group of engineers. I don't know when, but it's prior to 1925 because Mr. Dethridge on the left died in 1925 and he was the Victorian engineer. It is taken at what was then the Commonwealth Parliament House, which is now Victorian Parliament House in Melbourne. Mr. Dethridge is the man who invented the wheel, the Dethridge wheel at the irrigation area. The only mention of him anywhere is a monument to him and his wheel out at Griffith today, because that wheel is so important. It measured the amount of water, and apparently he invented the thing but didn't even patent it. But he cracked up under the strain of 1925 when they couldn't find solid bottom. But that's how the gentlemen of the day looked. They all look pretty old, don't they? Nobody smiles, but they probably, by today's standards, wouldn't really be that old. But that's how they looked at that time. This is the quarry around near the Bathanka Bridge and a couple of kilometres from the site, and one of the reasons they chose this site because of the quality of the granite. The crushing plant was around here, was the one that was hauled out by 2 traction engine in 1919. It could take an 8-tonne boulder and reduced it to 2-inch pebbles, and they could arrange the crushers to make whatever size pebbles they wanted. So this was used in the concrete on the New South Wales side all the time. The Victorians only used this occasionally. Now this had its own generating plant at Kelly and Lewis. You can see the steam cranes on railway lines. I don't think they were self-propelling, you just pushed them along with manpower. And they had a separate crew here, although the crew lived at the village in town, a couple of kilometres away, and came out every day by train or something. But all the trucks on the New South Wales side were loaded here with either plums or small granite and fed by gravity back to the construction site around where the works area was. This again is the quarry. The quarries, of course, always had a floor and a face, the face on which to work, the floor on which to work and the face to which to work at. You see a mixture of railway gauges here. The gauge there is very, very broad for that steam navvy up there, but most of these gauges here are 3 feet or 900 mil that were used on the New South Wales side. Again, remember, the crushing plant is down below this level here, and the trucks went back by gravity back to the construction site near the wall. We're overlooking the Murray Valley there at the moment. Of course, it's full of trees, but eventually, in a few years, it will be full of water. Again, you can see a few horses around here, so obviously some horses were used in this area. This is all that remains of the site today. It was obviously too solid to be removed. It still stands there today as a sole monument to all the people who once toiled there. But you're looking down at the Murray Valley with only a little bit of water in it. Looking in the middle of the picture is the Mitta Valley. And all of that would be filled with water as the weir gradually filled. This is 1924. This is the Bathanga Bridge. As the waters of the Weir rose, it was to flood a bridge at Tallangatta and Ebden, and it was decided to build another bridge at what is called Bathanga today. This must have been decided early in the 1920s because tenders were called worldwide for its erection, because it was not known when the time came whether there would be water underneath it or dry land, and only 2 people tendered for that job. The bridge was actually made by Ruwald, a Melbourne firm at Richmond, who up until 1913 had been at Wangaratta and had made mining dredges. And that firm was called Vickers Ruwald in Melbourne 50 odd years ago, but today they have gone. So Ruwald's made the spans. There were 9 spans, each one spanning 80 metres, and they arrived at the Victorian site by broad gauge railway line and were hauled around by horse-drawn timber jinkers up that steep hill, what is now past the trout farm, to the New South Wales side of the bridge and stockpiled there for a number of years beforehand. One wonders how many tonne a team of horses could pull up that steep hill. There's thousands of tonnes in the whole bridge, and it must have been going on for years and years. In 27, work started on the bridge in January, and the first 6 months was spent in building a bridge across the Murray River, which you can just see here. The bridge, of course, had no sides, as these bridges didn't, with a railway line in the middle, and putting on water and power to the site. That occupied the first 6 months of 1927. Then came the erection of 8 of these towers. They were over 30 metres high. They're about 3 metres in diameter. They're hollow. And they invented a system of a continuous pour, and they jacked the boxing up on the steel reinforcement. But first of all, they had to find solid granite 40 feet down. That's roughly where it was. On 3 of them, they couldn't find solid granite. So they went down a reasonable depth, then drove in piles and put down a concrete raft on top of that and erected these columns on top of that. Now, all of those columns were built in 12 months. They worked 2 shifts in the summertime, and in the wintertime they heated the water to help the concrete dry. But the structure you see right up on the top there is made of timber, would have started at the bottom. It was 4'6" high, about 1.5 metres high, and they poured in a lot of concrete, and when boxing was filled to the top, they jacked it up about 1 foot or 300 millimetres, and then poured in another batch of concrete. And by then the concrete at the lower end of the boxing was firm enough to stand the strain. So they erected all of those things. They dug the foundations, did all the formwork, and did them all in 12 months. An amazing thing. It was done by day labour. They even had a passenger carriage of 3-foot gauge that brought the people out to work from the New South Wales side each day. Now, that shows you the 8 columns, and bear in mind that along the top of them, if you could sight them, they were very, very accurately the same height as they had to be for the steel structure to go on them. And they had to have on top of them the steel bearing on which the steel trusses would eventually rest. So all the columns you see there have gone up in 12 months. Now, at this stage, a Mr. Thompson comes into the picture. It only says Mrs. Thompson in a book I read. I suspect he was the Mr. Thompson from Thompson's Engineering of Castlemaine. And the same person might have driven the first steam car through Albury about 100 years ago. He won the contract to erect the trusses. He, while there was still dry land underneath, had a series of posts put in between each span. He must have had a dozen. And they were put in with a pile driver and must have been a few feet above the ground, on which he would eventually rest tall wooden towers to support the scaffolding work when he was building the bridge. It will be revealed in the next picture. These, he must have put 12 in each space. They must have been driven by a pile driver, and they must have been checked with a theodolite to make sure they were absolutely accurate. The steel was stockpiled on the New South Wales side, and this picture was taken from that area at the time. And this shows the first span in position. Underneath it you can also see what was called the falsework. It consisted of 3 towers that must have been about 6 metres square and were 30 metres high, and they were floated out because there was water there when erection time came, floated out and fixed by divers onto these columns and somehow or another pulled upright. I don't know how, I've never worked it out. Obviously with block and tackle off the concrete pile. When those 3 towers were put in position, 4 horizontal trusses were mounted between them, connecting the concrete piers and the 3 towers. And when all of those things were put in position, they had a curve in them over that 80 metres of about 3 inches curve. When they erected the steel by laying out the horizontals, standing up the verticals, and then putting in the diagonals, and they were riveted together with red-hot rivets, and men suffered from burnt hands all the time. The red-hot rivets were heated in little furnaces driven by hand all the time. And when they'd driven the last rivet and pulled out all the scaffolding underneath, the 3-inch curve disappeared and the bridge became perfectly level. And that happened in the 9 spans. Once the scaffolding was in place, they put up a span in 21 days. It seems unbelievable by today's standard. I've never yet met anybody who actually worked on the bridge, but it was all built really in about 2.5 years. This picture shows 2 spans in position, and the 4th work, as they would call it, is being erected in the 3rd span. At this stage there is water in the weir, so as I said, a diver was used to locate and fix the wooden towers onto the existing stumps that were in the ground. But how they lifted them up is beyond me. When a job finished and they dismantled it all, they had to float it around to the next opening and stand it all up again. But in spite of all of that difficulty, all of those spans were put up in 12 months. It seems unbelievable by today's standard. Nobody fell off the bridge. Sydney Harbour Bridge, 16 men died altogether, although some of them at the quarry down at Nowra. This was overshadowed, of course, by Sydney Harbour Bridge. It came out from England, designed by Dorman Long and put together like a Meccano set. This one was made in Melbourne and erected by men living in this area. It was all Australian. It was opened without any fanfare in 1930, and there's not even a plaque on it today to give any credit to anybody. In this picture here, it appears that 3 spans at least are up. We can't see the rest of them, but the interesting thing is the punt. This was the punt originally made to take the Bucyrus across the river, and was also used as a pile driving punt. In August 29, it had to be brought around here and converted into a punt because the 2 bridges connecting both sides of the river went underwater. And this was the only way people had of getting across. It was nearly 1 kilometre across the river, and that was nearly the length of the Bathanga Bridge. The voyage took about half an hour. It pulled itself across on a cable. But eventually, after serving for a short time here, this became the Weimar punt. But then, of course, it was made of timber and eventually deteriorated. There's still a punt at Weimar today called the Weimar punt, but that's not the original punt. This one was sold and chopped up for firewood some years later. So, apart from work at the weir, it also served up here. There was only one great thing that always mystified me. All the time I knew of it, it was doing work below the spillway, right up until 1928, getting the Bucyrus around in pile drivers. And suddenly, in 1929, it's upstream of the weir wall, and I've never worked out how they got such a big structure as this over the wall to this site. It couldn't come by road. It must have been floated up. Did they perceive this difficulty arising in the spring of 29 and get it upstream while there was still a gap in the wall? I've never worked that one out. It remains a mystery. This shows the punt. The elevated structure is to lift up the ramp at each end as it travelled with those ramps elevated and lower them when it got to the bank. It apparently always had that launch alongside. It was the only lifeline if anybody had to be rescued. You can see the motor vehicles on board, and one vehicle obviously has a load of wood. There were no hard tops there. This is 1929 this happened. I can recall as a youth going across there, and for Albury people it was a wonderful experience to have a boat ride, the only opportunity we ever had. It was only used in the spring of 1929 because the following year the bridge was finished, and then it went up to Weimar and became known as the Weimar Punt. Now this shows another view of the Pathanga Bridge taken from that very punt by the late Mr. Stuart Mackenzie Logan, who took these pictures, otherwise I wouldn't have a clue as to how it happened. But there you can see two of the towers in position and two of the horizontal trusses lifted up. Again, I can only say how men handled those things under those conditions at that time, I do not know. But that span is actually 268 feet. I've said 80 metres, that's approximately, and they're 30 metres high. And today's traffic still travels on it. There's no load limit on it at all. It originally had a wooden decking. In the 1950s, the wooden decking used to rattle. You could hear it all over the weir. In the 1950s, when they were raising the level of the weir, they put new water-resistant bearings underneath it and put a concrete decking on it today. So today it's a silent bridge. But here it is, designed in 1920, still carrying today's traffic. One wonders, is it reaching the limit of its life? The gadget up there is called a creeper crane that the engineer designed for erecting his bridge up. That's all I can tell you about that. But other than stumbling across these pictures when Mr. Logan died, we wouldn't have any idea of how it all happened. So this, again, was a picture taken by the late Mr. Stuart Mackenzie Logan of Albury, long dead now, showing the creeper crane and some details of the horizontal trusses that the contractor would have used. The creeper crane ran on a railway line, hence the story that a railway line once ran across Pathanga Bridge, but it was only for the creeper crane. But the member jutting out to the right, I suppose, was a sort of a cantilever thing that maybe it was movable and it lifted trusses up and down, but they would have laid out the horizontals, the verticals, the diagonals, and riveted them together and built it up from that. And when all of these thousands of rivets were finally put in and the scaffolding was demolished, the bridge was dead level. Another view of the same structure. Obviously there's something up there from which the men are painting the structure. When you realise that this whole thing, all the trusses went up in 12 months, of recent years there's been a team out there painting the Pathanga Bridge, and they really seem to take years to paint one span, yet the whole thing was actually built in 2.5 years. People obviously just worked quicker. Nobody fell off the Pathanga Bridge, there's no reported accidents, and it's a great credit to the men who built it, especially Ruwalt's, the firm in Melbourne. They erected one of the trusses in their yard to make sure it all worked together. Possibly they only bolted it together instead of riveting it. This is a view underneath the bridge. Those columns are hollow, there's water inside them. And remember I told you they were made in a continuous pour that went up. The water level here varies an awful lot. I can recall in the year 1968 when the water level varied 100 feet or 30 metres, and a boat that was lost for many, many years was recovered. All of these structures standing in that water are covered in so much water for some of the time and in so much air. Normally 50 feet variation was the sort of variation we would have every year, but those structures have stood the test of time and they've been there and carrying today's traffic still. The weir is very, very low at this level here. When the weir is full, the water nearly goes right to the top of those. It's only a couple of metres underneath it. Well, the Pathanga Bridge, at the time it was built at about 1 kilometre, was about the longest road bridge in Australia. It may have been superseded today. And it was built in 2.5 years and was entirely Australian. All the trusses came from Melbourne. It's a wonderful tribute to the men that built it. It was opened for traffic in 1930. It originally had a wooden deck and later on got a concrete deck. The wooden deck was brush box that came from Coffs Harbour up in New South Wales. But it was a wonderful tribute to Australian engineering, and there's absolutely no recognition of it today. But there you can look at it, gaze at its beautiful lines and still enjoy it. And it was virtually made in Melbourne. This is the finished concept we see today in the year 2001. The weir today shows the superstructure on top that happened in the 1950s and 60s when the capacity of the dam was double and the water level was raised about 8 metres. This structure is really a monument to the men who built it. We know of 4 men who lost their lives. Many others carry scars. They're all dead today, but their descendants are around, but they know very, very little about it. And this video you have just seen is the only record in existence of this great work. It was the second largest dam in the world. It was entirely Australian. It was one of the new works of the new Commonwealth. It would have been financed by the Bank of England. Most of the know-how was all Australian. I don't know whether all the engineers were Australian trained or English, but we didn't bring in an overseas company to do it. We did it ourselves. It is something we should be proud of. No record of this great work would be complete without reference to the men who built it. They laboured with pick and shovel, horse and dray, and monkey-tail scoops and primitive equipment. They encountered many difficulties, even death itself. But the vast undertaking, the construction of the largest dam in the southern hemisphere, went on, and the picture you now see, with its great bulk and beauty of line, tells nothing of the trials of the men who built it. We see it as a source of water, a place of recreation, but it is a monument to those men who served in World War I and then on this great project. It is a monument without inscription.